Hello, this is Dr. Paul Cottrell, and I'm going to be talking about the polio virus and how the treatment for glioblastoma can be produced at the molecular level. All right. I did a previous video showing some scans, radiological scans of glioblastoma of patients in the different trials, trial 1 through 5, and some of the complications that may arise from that. So please refer to that video. But basically the idea is that someone would have a tumor, a glioblastoma, that's in their brain, and there's a catheter that's put in. So you're drilling through the skull and you're inserting a catheter into the tumor, and then you're drip feeding a solution that contains a modified poliovirus. And because these tumors overexpress CD155, that it's allowed to dock on these tumors. Now, I'm going to go into the molecular reason on why this particular treatment, this modified version of the poliovirus, is allowed to work on tumor cells, but it doesn't affect normal cells. So normal cells will express, normal neuron cells will express CD155, but these tumors do overexpress CD155. So that's one way to differentiate it. But there is a modification at the molecular level in the untranslated region of the 5'. So the 5' UTR, there's a change that is done that prevents this treatment from affecting normal neural cells. The problem comes in is that when they increase the dosage, that there may be an inflammatory response, and swelling may happen, and there's a pressure because of that swelling on the normal tissue that may cause seizures and other complications depending on where the tumor is. So, and this has been seen in patients when they were increasing the dosage, because the video I previously did was the study on what the dosage should be. Now, all these patients were, extremely advanced in their stage, and glioblastoma is a fast developing tumor that, if not treated, will lead to death. And there's not many months, that's available for the patient if untreated. So they're trying to come up with a treatment that is better than just surgery, just chemotherapy or radiation therapy. But, that video that I previously did, shows some of the complications that may arise with higher dosage. The purpose of this video is to go into some of the molecular biology. Because of the complexity of this is going to have to be 2 videos, perhaps 3 videos, to really dive into this. But with that said, let's start this. So basically, we have a polio virus, all right? And just to give you a little bit of a primer on the polio virus is, I don't know, around 7,000 or so, a little bit more than 7,000 nucleotides long. It's a positive RNA. And it can lead to individuals that could become paralyzed. Okay. Now, there on this screen, there are three types of genomes of the poliovirus. So let's zoom in, all right, and let's kind of go into a little bit of the detail here. I don't understand why this is not. Hold on. Complications. Okay. All right. So on for figure A, okay, there is a, just to do some basics here. So you have a 5' and you have a 3' untranslated regions. That's the UTR. Okay. And then you have the open reading frame, which is the bulk of, the proteins that are going to be expressed from this messenger RNA. So what you're seeing here is a messenger RNA. This is a messenger RNA. Okay. Now, this region that's really important, and I'm going to go into detail, is what is called the IRES. All right. Now, this helps with the recruitment for the ribosomes to start to be able to translate the messenger RNA into protein. And that code, the coded region is this, okay, the open reading frame. Okay. Now, there's topology here in the 5' untranslated region where there's complementary connections that are taking place. All right. These are called hairpins. All right. It creates a structure, a three-dimensional structure. Okay. Now, that three-dimensional structure can recruit or promote binding of certain complexes. So we're going to go over a complex binding of this ELF, 4G, 4A, 4B, okay? But then there's a modification that takes place for the live attenuated vaccine. That's a single point mutation. And I believe that point mutation is I don't think I put it in my notes on what it is, what location. Yeah, I didn't. Maybe I can find it. Hold on. There's a point mutation at G480A. Okay. Now, this point mutation is through actually serial passage in a primate tissue. Okay. The problem comes in is that this method can allow for this to go back to wild type. Okay, so this is wild type. And this is a mutation for the attenuated vaccine, the Sabin. Okay, but the problem is that it can go back to wild type with these point mutations. Okay, now the actual treatment for glioblastoma is a modification. in the 5' untranslated region. And this region here is a chimera, and it's a combination of the Sabin, but also the rhinovirus. So this is a chimera, right? And it has a certain property, and I'll go into that. Basically, and I'll go into the details, but basically, this mutation, this chimera allows for it to translate in tumor cells. Tumor, for the glioblastoma, not in normal neurons. Okay. Now, part of the reason is you got to remember in the tumor cells, there's an upregulation of the CD155, but also in the tumor cells, these are tumor cells of the glioblastoma, they also have machinery where it prevents the recruitment of certain things. All right. Oh, I'm sorry. In the tumor cell, let me rephrase that. In the tumor cell, there is an increase in the CD155. And in the tumor cell, there are things in the cell that's going on that allows for recruitment to take place. So in a normal cell, there are inhibitory factors that prevent recruitment in this region. But in the tumor cell, it allows for recruitment, and then it allows for the translation. And then because we have proteins that are taking place for the PVSRIPO, or I'll just call this the glioblastoma treatment, it'll recruit immune cells to start trying to kill the tumor cells. So in the tumor cell, we have the mechanism to recruit to the IRES, okay? And then that'll allow for proteins to be created. And those proteins are going to start to help to elicit an immune response. And then the immune cells start to kill the tumor. And this is only happening in the tumor cell, not in the normal tissue. Now, normal tissues can be affected when you have too much of a dose of the PVSRIPO. Now, remember, this is a poliovirus that's attenuated, but it's a chimera between the Sabin and the rhinovirus. Okay, so higher dose, then it can affect the normal CNS cells because of too much inflammation and pressure, increased inflammation and pressure. Right? Okay, now let's do a whiteboard here. Okay, now we're going to go into a little bit of the details of this. Okay. And this is a little, this type of treatment is kind of unique. It's using a virus to actually, a modified virus to actually kill a tumor by eliciting an immune response. So let me just, you have the brain, right? You have the brain. Here's the skull and here's the brain, the two hemispheres. And let's say you have a tumor that's growing right here. Basically what they do is they put tube here and then they drip feed the solution. This is the treatment, the PVS, right? PVSRIPO, I think it's called. All right. Now, when you do that in low dose, it's going to start over time. It's going to, over about 5 months or so, you're going to start seeing this shrink because it's recruiting immune cells and they have antibodies to try to attack. Now, what's happening here is that in the cell, in this tumor cell that took in this treatment, it's going to start it's going to start presenting it's going to start presenting proteins from this, certain proteins, and those proteins are going to elicit this MHC2, right? MHC2, and then you're going to start building up antibodies. And then those antibodies are going to go in and start attacking the tumor. Okay, that's basically the idea. In high dose of this treatment, what happens is that it is eliciting antibodies, but it's also eliciting, because it's not just antibodies, you're also increasing interleukins, right? And it's going up in that pro-inflammatory response. All right. So when that's happening, there's going to be swelling that happens. Because of that swelling in high dose, you may actually herniate certain structures within the brain, and it can cause seizures and problems with eyesight. Depending on where the tumor is, depends on what may happen. But so complications can arise from this. All right. So it seems like lower dose is better than the high dose. Okay. Now, all right. Now let's go into the molecular biology of this. All right. Let's start with conventional. All right. Protein synthesis. What really happens? What happens normally in a cell, right? We have something called EIF4E. Okay, EIF4E. Okay, this is eukaryotic initiation factor. Okay, 4E. There's different types, and this binds, right? Binds to a what is called a 7-methyl guanidine cap. Okay, and this is at the 5' end of the RNA. Now, remember what I was saying about the UTR, the untranslated region, and the 5' is where the initiations are taking place. Well, this is what's happening. So normally the EIF binds to a certain region on the 5'. Okay, and then once that happens, then what happens is it recruits EIF4G. So it needs EIF4E to bind to a 7-methyl guanidine cap, and then all of a sudden it will start recruiting EIF4G. Now this is going to be important. And then what happens then is that it builds up this complex called EIF4G 4A 4B. And that you saw on the picture that I showed you. Okay. Now this is a helicase complex. What this does is it's what this is doing is it's scanning at the 5' UTR region. It's scanning and it's unwinding. Now, you got to remember that there's a 3-dimensional structure for the 5' UTR. So this is kind of helping to kind of unravel it a little bit. And by unraveling it, what's happening is that eventually it's going to find the initiation codon. Initiation codon. Okay. And it also helps to bind the EIF3. And what that does is it helps to bridge for the small ribosomal unit, subunit. So you have this messenger RNA, 5', right, 3', and you have this region here that's the UTR, and it's recruit. Now, normal. This is normal. This is the conventional way, right? So we're just going to start with normal, and then we're going to go to abnormal. So there's a region here that is the 7-methyl region, the guanidine, all right, and then it's going to bind the EIF4E, okay, and then the EIF4E is going to bring in EIF4G, right, and then that's going to build another complex, which is 4A 4B. So you're going to have all this complex, and it's starting to unwind, and it's starting to find the initiation codon, okay, and it's moving this direction, and then this complex here is also bringing in this EIF3, and that's all allowing for the lower subunit and the big subunit for the ribosome. So you have a large subunit and a smaller subunit of the ribosome, and then that's going to allow for the protein to be created. So all this stuff here is basically the initiation factors that are needed to allow for the ribosome to come in and hold and start. Okay. Now, let's talk about the poliovirus. Some people don't like my handwriting, but I really don't care. All right. The RNA is uncapped. and what that means basically is it's going to cause problems with the EIF4E, right? So it cannot bind to the EIF, which was the first step in the normal way of things, all right? So it doesn't use it, all right? It doesn't use it. Nature has allowed the poliovirus to recruit that complex, the EIF4G, 4A, 4B, independent of the EIF4E. All right. And because of that, it doesn't need this cofactor, right? It can recruit this directly, and this will bind to the 5' UTR region that is, this RES region. That's really important, okay? The structure of this is approximately 500 nucleotides. Now, in normal cells, normal neurons, right? You have a recruitment of EIF4G, okay, to the viral genome. In normal neurons, there's this EIF4G viral recruitment, okay? And this is the reason why polio can affect normal neurons, the wild type. Now, if you substitute this region, this IRES region, now what we're going to do is we're going to call it RV2. They call it HRV2. Then what's going to happen is that you're preventing, if you substitute this region, you're breaking this connection. So what you're doing is you're eliminating the ability of EIF or G recruitment. And this happens to be, this modification, this substitution is in what is called the distal part, 1/3 distal part of the IRES in the 5 UTR, the 5' UTR. And this is in domain 5 and 6. Now, the issue with the Sabin IRES region, now remember, this is the vaccine, that's the polio vaccine, that's the single mutation, right? Now, the issue with this like I said, was that point mutation that you have a point mutation and it can revert back to wild type. So now let's talk about the actual treatment of the glioblastoma at the molecular level. All right, so what happens is that the neural the neural defects in recruitment. Because we want to, the whole point here is that make a treatment where it's not allowing for the virus to work in normal cells, but only in tumor cells. Stop the protein creation of the virus, the modified chimera virus, in normal cells, but it would work in tumor cells. So that's this point here. Now, in the host cell, so this is the neuron, the RNA binding proteins, they interact with the HRVSIRES. Okay, this is again at that 5' UTR. This is that modification that I was telling you about. Okay, this is that chimera modification. So in the host cell, the RNA binding proteins interact with this region. Okay. And when the binding proteins interact, then it prevents this from being transcribed. Now, this is normal. This is the normal host cell. Okay. Now, and then and/or interaction because of this RAF ERF pathway. Okay. RAF ERF 1 and 2. All right. This is what is called a mitogen activation protein kinase pathway. MAPK. Okay. So this is absent in normal cells. This is activated in tumor cells, but not active. It's absent in normal cells. Normal cells. Okay, so normal cells, you have this binding protein on the IRES, and then you also have an absence of the RAF pathway. You know, that MAPK pathway. This is absent in normal cells. In tumor cells, what happens is the binding proteins are not interacting with the IRES, and it's allowing for that cofactor that we mentioned before, the EIF4G cofactor, to be recruited. Okay. And when this is happening, it's restricting ribosome recruitment. So when this is absent, it's restricting the ribosomal recruitment. When it's active, it is bringing the ribosomal recruitment. And that's the reason why this would work. And then the poliovirus chimera, right, is fully translation proficient. In tumor cells. All right. All right. So let's go back. All right. VISP, clear it. PVSRIPO. This is the treatment for the glioblastoma. All right. And this is a chimera between Sabin polio and the rhinovirus. Okay. In this IRES region. Okay. It works because it works in tumor cells because, right? Because tumor cells have an increased RAF. 1 and 2 increase in the MAPK. And because of that, it will allow for ribosomal recruitment. All right. And then that will lead to increased protein, which would increase immune response. Which would kill tumor. Okay. So the treatment for the glioblastoma is this chimera virus. And the reason why is that the RAF-ERF pathway is upregulated in the tumor cell, in the glioblastoma, not in the normal cells, and the ribosomal recruitment. In addition, you also have less in the tumor cell and you have a decrease in RNA binding protein in the RVS 5' UTR in tumor cells, right? In the tumor cell. All right, which this will allow for the EIF G4 or 4G, 4G AB, I'm sorry, not AB. 4A, 4A, 4B complex to bind. And then that also increases the ribosomal recruitment. Which would increase protein. Of the virus, which would increase the immune response. Which leads to antibodies against the tumor, against the tumor cell, and not just antibodies, but it's also going to bring in the natural killer cells and the CD positive cytotoxic cells, CD8s. Okay, so when it is a tumor cell for the glioblastoma, you have blast binding RNA proteins, which allows for EIF4G binding at IRES. And then you have an increase in the RAF pathway, MAPK. Then what will happen is that the proteins in the cell, the proteins for the virus, this PVSRIPO, right, proteins start to increase, right, and that will elicit an immune response, and that will, one, it will increase antibodies. It will increase CD positive, CD8 positive cytotoxic cells, and then it will also bring in the natural killer cells. All these will start to kill the tumor, not normal cells. Okay, so let's review again. Okay, so there is a tube that is drilled basically in the skull and put into the tumor. What happened? Oh, I think I just deleted it. There we go. All right, so there is a solution that's put into this tube that's feeds right into the tumor, and they drip feed this about, I don't know, 8 hours to maybe 12 hours, right? Maybe even 6 to 12, depending on the size of the tumor. All right, but it's slowly dripped in. All right, and then it takes several months to actually see recession in the tumor. And when you have low dose, it's more effective than the high dose. Now, what happens in the high dose is that there's more inflammation and swelling in the brain and causing side effects, potentially even death, because of the herniations that can take place depending on how much of swelling is taking place. All right, and so it's bringing in antibodies, it's bringing in natural killer cells, it's bringing in the CD positive cytotoxic cells. There's, the interleukins are pro-inflammatory interleukins. This whole pro-inflammatory response is starting to increase. Okay, now then we talked about the conventional. What's the conventional way of the protein to be synthesized in a normal cell? What's the conventional way? All right, well, you normally need this EIF4E cofactor, and that will bind to a 7-methyl guanidine cap that's on the 5' end of the RNA. That will recruit something called EIF4G. Okay, and then that will help to build this helicase complex, which is called EIF4G4 4A4B. This right here will help with the binding of an EIF3, which helps to bind the small part of the ribosome that's binding to the messenger RNA. In addition, this helicase complex is also scanning and looking for the actual initial codon. All right, and it helps with the unwinding of this topology that I mentioned before. Now, with the poliovirus, it is an RNA it's uncapped, okay? So it doesn't have the 7-methyl, doesn't have the 7-methyl guanidine structure, okay? So it can't recruit the EIF4E, right? It can't bind. So nature has allowed for the poliovirus to evolve and be able to recruit the EIF4G, 4A, 4B directly, all right, based on the topology that's in the IRES region of the 5' UTR, okay? This IRES structure is about 500 nucleotides. Okay, now, in normal neurons, we have a recruitment of the EIF4G, okay, to viral, to the viral, to a viral genome. And if you substitute that area, then you eliminate the ability of this to actually, because you got to remember, this has to bind to allow for proteins to start to be created from the virus. Okay. But if you break that connection, if you break that binding, the proteins can't be made. They go down, right? So this is where the molecular biology comes in. If you substitute this IRES region, then you're eliminating the ability of the EIF4G to be recruited. Now, this happens to be in a domain in the IRES of about the 5-6 domain. It's the distal part of the domain of the IRES. And, it's preventing this binding of EIF4G. Now, when you do that, then when you modify it, then in normal cells, it won't be able to translate the protein of the virus. Okay, now the issue with Sabin is that it's a point mutation. And that point mutation can go to a wild type, okay? So the idea is, okay, how do you make it more robust? So it's modifying the Sabin poliovirus and making a chimera with the rhinovirus. Okay, that's this. So that's the PVSRIPO, all right? Now, neural defects, so, why does this work? Why does this work? Okay, so this, in normal cells, a normal neuron, right, will have these RNA binding proteins that bind to the IRES region and prevent the EIF4G, 4A, 4B complex from binding. Okay, it'll prevent that in the normal cell. Okay, so there's proteins that are allowed to prevent this from happening, and in normal cells, RAF is not activated. The the MAPK is low, right? So it's because of this, it's doing a restriction on the ribosomal recruitment. So there's this combination of binding proteins preventing the chimera poliovirus from translating, making protein, right? And it's using the normal cells don't have this activated RAF pathway. So you don't get the binding of the EIF4G complex. Now, in tumor cells, that's different, because in tumor cells, you have increased RAF and increase MAPK and decrease in RNA binding proteins. Now, the reason why there's a decrease in RNA binding proteins is that you got to remember a tumor cell increases cell division. So because it's increasing cell division, it has mechanisms in place to inhibit the RNA and the RNA binding proteins, so they'll go down. So when cell division is happening, you want to bring down the RNA binding proteins that inhibit, you bring it down, because these RNA binding proteins, they're inhibitory for protein synthesis. All right, now, okay. Now this chimera, the Sabin rhinovirus, this IRES region, this chimera, right, the PVSRIPO in tumors, like I said, you have this increase in RAF, you have an increase in MAPK. This allows for ribosomal recruitment. Ribosomal recruitment increases protein of the virus. This is a viral. Then it has an immune response, and then it recruits cells, antibodies, and kills the tumor. Okay. And then the other pathway is the RNA binding protein. The RNA binding proteins in the tumor cell will go down because it needs to do protein synthesis, right? And then you'll have this binding of the EIF4G complex on the IRES in the 5' untranslated region, right? And when you have that increased recruitment, that increased binding, then you will increase the ribosomal recruitment, you'll increase the proteins from the virus, and you're increasing the immune response, which are antibodies, natural killer cells, and CD8 positive cells, and cytotoxic T cells. All right. So now, and this is just a repeat of what I just said in the tumor cell. What's going on here? Now, I want to go back to that picture that I showed you. Okay. Now, here, again, now let's just go back to what we were starting with at the very beginning. Now everything will start to make sense. Okay, again, you have that 5' untranslated region, the 3' untranslated region. You have the poly A tail. You have these hairpin structures, and that topology of the hairpin structure will allow for the binding of this complex. Okay. Now, remember that the poliovirus does not have the 7-methyl guanine, right? Guanidine cap, right? It doesn't have it. So it's evolved in a way where it does not need the EIF it doesn't need the EIF for, what was it? C. For E. It doesn't need it. And it can recruit this directly. Okay, that's the wild type. Okay, I believe this was isolated from a fecal matter of a healthy child. I think that's the history of that. Then once this binds, then it's starting to recruit the ribosome. You know, it's scanning for that initial codon. And then it's also recruiting cofactors for the lower part of the ribosome. So you have the upper part of the ribosome, the lower part of the ribosome, and it'll start to create protein. Create the protein by the coded frame, this open reading frame, the coded region. Okay, so we clear that. Now, the Sabin live attenuated, this is a single point mutation. Okay. And here is the actual treatment for the glioblastoma. This is that chimera that I was telling you about. That region is right here. And now my understanding is that 6. So this is why we said distal domain 5 and 6 is affected. Okay. Now, with this, this is designed in such a way where it will code for protein. It'll code for protein of the virus in tumor cells only, not normal, not normal neurons. Okay. It's only in the tumor cell. Now, why is that? Well, it is because you have a decrease in the RNA binding proteins that inhibit, these binding proteins inhibit it inhibits the that complex, that EIF4G, right? Complex. Well, in the tumor cell, it reduces that. So that basically means that you're going to have increased EIF4G recruitment. when you have increased EIGF4G recruitment, then you're going to have increased protein production of the virus, of this chimera virus. And when you increase that protein, then what's going to happen is you're going to increase the immune response. See, the problem with the glioblastoma is that there's no immune response to try to kill the tumor. The idea is to create an immune response to bring in the natural killer cells, bring in antibodies, and bring in the CD8 positive cells, right? And then you start killing off this tumor. So hopefully that gives you a better idea of using something that could harm you, but if it's modified in such a way, it could actually be a targeted therapy for such as glioblastoma. Now, I think that was kind of an interesting take on it. I'm going to do another video to go into some of the receptor aspects to this. But I think this video was really important for individuals to get a better idea of what was going on at the molecular biology level to change the chimera in such a way where it can be targeted. Now, to help support my work, please go to my website. It's the-studio-reykjavik.com. And at the very bottom of the homepage, you can donate through Stripe or PayPal. And that will help to support my news coverage. But better yet, please go to the store and purchase the products that will help to improve your health. Please, take a look at the nano silvers I have. I have C60, which is a very strong antioxidant. I have a plethora of different supplements, all the way from D3 going, through zinc and clarity factor and turmerix, right? And then I have all natural deodorants. And then I have these great anti-aging boxes, which I curated and helped to, to produce for you to just do a one-click button kind of thing if you're interested in, protecting yourself against, let's say, Fauci. All you got to do is click this, and what is the things that you need? Well, you neutralize pathogens with Max 35. You help with the apoptosis with D3. The zinc will help with fighting infection. Turmeric lowers the inflammatory response. Ashwagandha controls the blood glucose levels and also brings down the inflammatory response. And then the advanced box would have the advanced Fauci box. Would have the anti-Fauci box would also have the C60. So, and that's a strong antioxidant. But, it's not just anti-Fauci boxes, it's just anti-aging in general. The whole idea here is you bring down, you can slow down the aging process by neutralizing pathogens, right? Neutralizing pathogens with the nanosilvers, bring down that reactive oxygen species in your cell by taking the C60. And when you do that, you're bringing down the stress of the cell and you're increasing your mitochondrial health. You're bringing in more calcium, you're absorbing more calcium, and you're helping with gene expression with the D3s. The vitamin C's and the magnesium is a great supplement that you need for your just natural everyday health. But vitamin C is really important for skin health. The This toothpaste that I have is extremely powerful. You know, it's neutralizing pathogens. It is the best toothpaste that you're going to be able to buy. All natural deodorants from essential oils from the Himalayas and probiotics, right? So, you know, this is a great way just to get started. Here's an advanced box for anti-aging. But you don't have to just, you know, go and get the stuff from the anti-aging box section, but you can buy individual products, right? You know, you can get the toothpaste and the Max 35s, the gels, the soaps, the lozenges. These are all really, really important products to slow down that aging process, because with the nanosilvers, you're neutralizing pathogens. And when you're neutralizing pathogens, you're saving the energy of your immune system so it doesn't have to constantly fight. So if you're neutralizing pathogens in the early stage, you're not going to get a cold. You're not going to get as sick, right? And so, you know, if you're not having a cold for 4 or 5 years, you're a lot better off than someone that has a cold, you know, every 6 months or every 4 months, right? Because once you have a cold, your immune system, right, is somewhat down, even if you cleared the infection. It takes a while for your body to get back to normal, to its normal state, you know? And if you're constantly sick, then you got a problem and your immune system starts to get weakened. So neutralize pathogens early in the development of a cold is really important. I have really excellent soaps, excellent quality soaps, and the lozenges. We're in the cold season right now, so it's really important to get those multivitamins and neutralize the pathogens with the liquid nanosilvers like Max 35 or Max 14, or even the pH balance alkaline silver solution. Now, C60, I offer it in 2-ounce, 4-ounce, and 8-ounce in avocado or coconut oil. It's a very strong antioxidant. I take a teaspoon of it a day, and you get the best benefits if you're taking it on an empty stomach, the best absorption. And what will happen there is that you're going to reduce the reactive oxygen species in the cell. You're going to bring down that stress, and you're going to improve the mitochondrial health of the cell. You're going to get more energy, and you're going to start seeing that the cells that are in your body are going through less necrosis. You're aging less, right? Over time, you're going to see that. Not only that, if you take it before you work out, you'll notice a huge benefit in terms of recovery. Now, the boomer products, I have a lot of them. D3 helps with gene expression and helps to absorb calcium. It also helps to get rid of cells through apoptosis. Vitamin C, really important for your skin. Omega-3, really important for your cardiovascular health. Ashwagandha, to control your blood glucose levels. Good night formula, has tryptophan and melatonin in it. This is going to allow you to get into those 3 REM sleeps that you need to solidify memory and to reduce cognitive dysfunction. The probiotics, that's going to help with being able to have proper absorption, and you're going to have a better metabolism. Resveratrol, strong antioxidant, but it also helps to get rid of senescent cells. So it's part of the anti-aging protocol. Vitamin B complex. These are cofactors that you need for different metabolic processes, especially in the electron transport chain. So if you're low on the B complex, you're not going to be able to generate energy as well. Turmeric, very excellent way to bring down stress on your body by reducing inflammation. Zinc, I take this daily, but if I'm sick, I'll take a double dose of it. So it's really important to keep your zinc levels at a decent decent level, especially if you start to feel sick. You catch that cold really early by taking an extra zinc. Lignans, great for hormonal health, but also it's it'll help with the immune system. I mix this with my probiotic. I take it in the afternoon with hummus. I mix it with hummus. It's in a powdered form, and then take it that way. Collagen, really important for skin health, and also for remodeling those joints, especially when you're older and you've had some sort of sports injury. Doing some sort of light resistance training on the sore joint, taking D3, taking collagen, taking calcium. I would suggest drinking milk for your calcium, if you're trying to remodel some sort of joint problem. And over time, what you'll notice is that you'll start to get an improvement. Digestive enzymes. As we get older, our pancreas starts to wear down, and we need to get those enzymes to be able to break down those carbohydrates, those proteins, and those lipids. In addition, when you work out, you need to refuel your body, and to reduce the load on your pancreas, taking this supplement as a way to improve your refueling after your workout is suggested. Now, Clarity Factor, a great product that will reduce the brain fog. A lot of people have brain fog. You take this product and you'll notice that will go away, and you'll be able to concentrate better. I have all natural deodorants that Rainbow Herbals has made from essential oils from the Himalayas. So I have it in citrus and deodorant, a citrus deodorant, and a peppermint lavender tea tree deodorant. All essential oils, very high quality. It's also kind of a detox. So, you're using a deodorant and a detoxification. It doesn't have any aluminum in it. It's very high quality. Then there's also this other product. It's called the Even Better Bar, and it's great for muscle pain, itching from a bug bite. It'll help to heal an abrasion or a cut. It would help with acne, and if applied every day to the skin, you'll notice that your skin will start to soften. You'll start to have a smoother skin, because of the types of ingredients that are in the bar from these essential oils, these high quality essential oils. And then again, back to the anti-aging boxes, I procured all these different, or curated all these different boxes for you is a one click to be able to get on your journey for anti-aging, right? The whole idea here is bring down pathogens by neutralizing them, bring down the reactive oxygen species by using the C60, and reducing inflammation by taking the turmeric and the ashwagandha. And when you do that on a regular basis, you're going to improve your health. But you can also add stuff to this protocol, like the B complex and the zinc and the Good Night formula and the Clarity Factor and the omega-3. The more you add to the protocol, the more systems that you're going to target to be able to improve your health. And you do this on a regular basis, what you'll notice is that you will age slower than your peer group that is not doing anything. Proper diet, proper exercise, proper nutrition, proper supplementation, and proper mental challenging, reading and writing and talking to people. All of these mixed together will improve your health. So, that's my suggestion. It's up to you to make that climb, for your health. So please subscribe to all 6 channels that I have. I have 3 channels on YouTube. The link is in the description of this video. So please subscribe and click the notification bell for YouTube. for all three channels. Also subscribe to my Patreon, my Bitchute, and my Rumble channel, and you'll see videos that have been censored by YouTube there. So that's the reason why you should subscribe to all 6 channels. For the ones that would like to support my work, my news coverage through being a subscriber to Patreon, I would greatly appreciate it. The link is in the description. Just click the link for Patreon and then subscribe, to be a paid member. That will help to support my news coverage. You can also donate through Buy Me a Coffee. The link is in the description, and that will help to cover my news. Now, take my advice, please. I have a lot of neat information and unique perspectives on different topics, not just on the science realm or the medical realm, but also on the financial realm and just overall news and different perspectives on things. So I greatly appreciate the people that watch, and I greatly appreciate the people that share the links and share articles and stuff with me behind the scenes, in the emails. So thank you for your support. Make sure, please, get the products from the store and help get healthy and maintain that health. Follow my lead and follow my advice, and you'll start to see the benefits. It's high quality products, and if you want to invest in yourself and have a more vibrant life, then I highly recommend to follow the protocol. Thank you for listening. Thank you for supporting, and have a nice day.